Right now, waves of electromagnetic radiation are bouncing off your body. They are passing through your skin, reflecting off your bones, and tearing through the walls of your room at the speed of light. To your router, you aren't a person. You are a localized disruption in the electromagnetic field. You are a cluster of phase shifts and amplitude drops. For 2 decades, we treated that disruption as background noise. But a new class of neural networks just figured out how to translate that noise into a flawless, 3-dimensional video feed. No cameras, no lenses, no infrared, just the router you bought on Amazon, reverse engineering your physical existence through solid concrete. Welcome to the era of RF sensing. The walls aren't just listening anymore, they are watching. For a century, surveillance required optics. If you wanted to track a target, you needed a line of sight. You needed a lens to capture photons. That architectural bottleneck gave humanity a final desperate line of defense: privacy behind closed doors. Computer vision shattered that bottleneck for the physical world, but it was still blind to what happened behind a curtain, a brick wall, or a locked door. Not anymore. What you're looking at isn't a camera feed. It's a visualization of Wi-Fi CSI, channel state information. Every time you move your arm, take a breath, or walk down the hallway, you perturb the ambient radio frequency environment. Your body absorbs and scatters the 2.4 GHz and 5 GHz signals radiating from your router. Historically, hardware engineers viewed these perturbations as signal degradation, multi-path interference that needed to be filtered out so your Netflix stream wouldn't buffer. But to a machine learning model trained on spatial architecture, that interference pattern is a goldmine. It is a highly detailed, real-time cryptographic signature of your physical coordinate space. Let's look under the hood of how this actually works, because it isn't magic. It's pure infrastructure engineering. Every modern Wi-Fi system uses a technology called MIMO, multiple input, multiple output. Your router uses multiple antennas to beam data to your phone or laptop. To keep that connection stable while you move around, the transmitter and receiver continuously generate a matrix of metrics. This is channel state information. CSI tracks exactly how the signal was attenuated, delayed, and phase shifted between the transmitter and the receiver. If you look at raw CSI data, it looks like absolute garbage. It's a chaotic, noisy stream of complex numbers. A human software engineer could stare at it for a century and see nothing but static. But this is exactly where deep learning thrives. Researchers fed this raw, chaotic CSI data into deep neural networks, specifically architectures like ResNet paired with spatial temporal transformers. The training phase is brutal in its simplicity. They place a human subject in a room monitored by both a traditional 3D optical camera system, like a Vicon motion capture setup, and a standard Wi-Fi link. The optical camera tracks the ground truth, the exact Cartesian coordinates of the human's joints. The Wi-Fi receiver tracks the distorted radio waves. The neural network's sole job is to minimize the loss function between the radio noise and the optical reality. It asks itself, given this specific distortion in the 5 GHz band, what is the most mathematically probable position of the human skeleton? After millions of iterations, the network learns to bypass the optical camera entirely. It maps the radio waves directly to a 3D digital twin. It can tell if you are sitting, standing, sleeping, or typing. It can read the cadence of your stride. It can even extract your respiratory rate just by calculating the microscopic chest expansions that alter the signal path. Now, the cynical response to this is, sure, it works in an MIT lab with custom hardware, but it won't scale to the real world. Wrong. It is scaling right now, and it's being branded as a feature, not a vulnerability. The tech industry is hitting a massive wall with traditional smart home devices. Consumers are inherently deeply uncomfortable putting optical cameras in their bedrooms, bathrooms, and private living spaces. It's a massive liability for device manufacturers and an invasive nightmare for users. But a router, a mesh node, you already have 3 of them in your house, and you ignore them. This has triggered a massive push toward device-free passive sensing. Companies are actively marketing this technology for elderly care. tracking falls in bathrooms without violating privacy with a lens. They're marketing it for smart HVAC systems, adjusting the temperature based on exactly how many bodies are in a room, even if those bodies are hidden under blankets. But here is the real kicker. This is becoming an official global standard. The IEEE, the governing body that defines the protocols for the internet, has a dedicated task group called 802.2.11bf. This is the official standard for Wi-Fi sensing. When Wi-Fi 8 becomes standard hardware deployment globally, RF sensing will not be an exploit. It will be baked directly into the firmware of the chipsets running the global internet infrastructure. The network will be structurally designed to measure the physical world. The democratization of this technology is moving at a terrifying velocity, driven by a profound shift in software development. We aren't manually writing algorithms to trace radio reflections anymore. We are using agentic workflows to build them. Look at how accessible this architecture has become. This is Trae IDE. It's a next-generation AI-native development platform designed to handle complex, cross-file contexts natively. If an engineer wanted to deploy a spatial sensing node 5 years ago, they needed a deep academic background in signal processing and custom highly unstable Linux kernels. Today, you open an AI-first IDE like Trae, drop in a raw repository of Wi-Fi CSI extraction tools, and let the environment reason through the data architecture for you. Using Trae's agentic capabilities, a developer can highlight a messy, multidimensional tensor matrix coming off an ESP32 microchip, a piece of silicon that costs less than a cup of coffee, and instruct the IDE to build a custom convolutional neural network layer to decode spatial movement. Trae doesn't just generate standard boilerplate code. It cross-references the underlying hardware constraints, optimizes the model weights for real-time inference on the edge, and structures the entire pipeline in seconds. We have entered the era of software-defined surveillance. The hardware is commoditized, universally deployed, and dirt cheap. The entire battleground is now happening in the software layer, specifically the high-speed optimization of the edge AI models that process this data. Trae and tools like it mean the barrier to entry for compiling deep learning models capable of wall-penetrating surveillance has dropped to zero. Let's talk about the brutal reality of the threat vector, because this completely upends our entire understanding of operational security and physical privacy. With a traditional camera hack, the attacker has to compromise your device's operating system, gain root access, bypass the kernel protections, turn on the camera peripheral, and stream high-bandwidth video data out of your network without triggering an alert. It leaves a massive digital footprint. RF sensing operates on a fundamentally different paradigm. First, it is completely passive. The radio waves are already leaving your house. Wi-Fi doesn't stop at your drywall. It bleeds into the street, into the apartment next door, and into the parking lot. An adversary doesn't need to break into your house to install a bug. They don't even need to hack your internal network. They just need to park a vehicle down the street with a high-gain directional antenna and a standard, off-the-shelf, single-board computer running an inference model optimized by an AI agent. By passively capturing the degraded radio signals leaking out of your home's windows and walls, they can reconstruct exactly what is happening inside your private residence in real time. They can see where your safe is. They can see if you're home alone. They can see what room you sleep in. And because they are merely catching stray photons that you are actively broadcasting into public space, there is zero digital signature. There is no log file to check. There is no firewall rule that can block it. You cannot firewall physics. So, how do you opt out? How do you patch a vulnerability when the vulnerability is the medium keeping you connected to civilization? This is the mitigation paradox. You can't paint your walls with RF blocking carbon paint unless you want to turn your home into an absolute dead zone where your own phone can't talk to your own router. You can't turn off the Wi-Fi unless you are willing to completely decouple from the modern digital economy. Some researchers are looking into RF cloaking, deploying active metamaterials or secondary transmitters designed to flood the environment with algorithmic noise, intentionally scrambling the CSI data so the neural networks can't find a clean mathematical correlation. But it's an arms race. Every time you optimize the noise, the next generation of neural network architecture becomes better at filtering out the adversarial artifacts. The brutal truth is that we have traded structural physical privacy for data throughput. We demanded a world of high-velocity, invisible, frictionless data connectivity. And the universe, operating on the rigid laws of physics, gave us exactly what we asked for. But it came with a hidden clause in the contract. Every radio wave we emit to consume data is a double-edged sword. It leaves our devices, hits our bodies, bounces off our bones, and carries the precise structural code of our physical actions out into the open air. We used to think of cyberspace as a digital realm separate from our physical reality, but through the lens of artificial intelligence, the physical world has simply become another unstructured dataset, waiting to be parsed, indexed, and completely exposed. Your router isn't just provisioning your internet connection anymore. It is compiling a continuous, real-time diagnostic report of your entire life. And there is no logout button.